Welcome to the next tutorial on this subject, Advanced Microwave Guided Structures and Analysis. So, this is the today we will do numerical problem on that calculation of wave impedance and power flow in rectangular waveguide. So, this is the first problem. So, an air-filled rectangular waveguide has inner dimensions of A is equal to 2.5 centimeter, B is equal to 1 centimeter. What is the wave impedance of the T10 and TM11 modes of propagation in waveguide at a frequency of 18 gigahertz? And because this is air filled rectangular waveguide, so here free space impedance is given 377 ohm. So, here A is 2.5 centimeter. So, we are doing first problem. A is 2.5 centimeter, B is 1 centimeter. So, we have to calculate the wave impedance of T10 and TM11 modes of propagation at 18 gigahertz. So, we know means eta t, that is the wave impedance for the T mode, equal to eta divided with, that is the wave impedance, that free space impedance, 1 minus f c upon f whole square. And for eta Tm, wave impedance is defined as eta square root of 1 minus f c by f whole square. So, like this we can define the eta Te and wave impedance for the Tm mode. So, here we need f c, cutoff frequency. We know cutoff frequency for each mode is different. So, for each mode cutoff frequency will be different, and according to that means we can see that eta t depends on eta. So, it depends on, it is air filled, electric field waveguide. Here it is the f c cutoff frequency that will depends on the, it is different for different modes, and it depends on also on the this operating frequency. So, it depends on f. So, for first we can calculate for T10 mode. For T10 mode, we know f c for rectangular waveguide. F c for rectangular waveguide is defined as u by 2 a square root of m by a whole square plus n by b whole square. So, a and b are the dimension of the rectangular waveguide, m and n is the mode number. So, for here for the T10, that means m equal to 1 and n equal to 0. So, we can substitute the value and we will get the cutoff frequency for the T10 mode. So, f, and here one more unknown is u. So, because this one is the air filled rectangular waveguide. So, u for the air means this velocity in the air field, u will be a square root of mu by epsilon. U is defined like this. So, for means it can be written as mu naught epsilon naught, no, this mu naught mu r epsilon naught epsilon r. So, it because this epsilon r equal to 1, mu r equal to 1, root under a square root of mu naught divided with epsilon naught, it will 1, means it will be wait. So, u in the rectangle, because this is the velocity. So, in the rectangular waveguide it is defined as 1 by mu epsilon, and it can be written as a square root of mu naught mu r epsilon naught epsilon r, because mu r and epsilon r is 1. So, it will be 1 by epsilon naught mu naught equal to 3 into 10 to the power 8 meter per second. From here we can calculate the cutoff frequency. Cutoff frequency will be Fc, we know M, N, A, B and U. So, from this we can calculate the cutoff frequency for T10 mode. So, Fc for 10 mode will be 3 into 10 to the power 8 by 2, M is 1 by A is 2.5 centimeter, but we have to keep it in meter, minus 2 whole square plus 0 by 1 into 10 to the power minus 2 whole square. From this we will get, so this will be, this will 100 will come out, and then 2.5, then 1 by 2.5, it will give 6 gigahertz, it will come 6 gigahertz. So, Fc for cutoff frequency for 10 mode, TE10 mode will be 6 gigahertz. Similarly, cutoff frequency for this TM11, one more is TM11. So, for this we can calculate the, first we can calculate the wave impedance for the TE10 mode. So, for NTE10 will be eta upon a square root of 1 minus Fc upon F whole square. So, eta will be this 377, because this is eta naught air field, divided with 1 minus Fc is 6 and F is the operating frequency. Operating frequency given is 18 gigahertz. Given operating frequency is 18 gigahertz. So, from this we will get, so in the denominator part it will come 377 divided with a square root of 1 minus 6 by 18, it will come 0.943 and answer for TE10 mode, N means TE10 mode will be 399.87 ohm. So, this is the answer for the first part, that wave impedance for the TE10 mode. Now, for the TM11 mode, again we have to calculate the cutoff frequency, then we will get the wave impedance for the TM11 mode. For cutoff, to calculate the cutoff frequency we can go by same method. So, this is for the Fc for 11, because this we can write, because this is mode independent. So, Fc for 11 will be U by 2 a square root of M by A whole square plus N by B whole square. So, here M equal to 1, N equal to 1, and it will be 3 into 10 to the power 8 by 2 a square root of 1 by A value is 2.5 centimeter, 2.5 into 10 to the power minus 2 whole square plus 1 by this 1 into 10 to the power minus 2 whole square. So, from this we will get the cutoff frequency for the TM11 mode. Cutoff frequency for the TM11 mode, after calculation it will come, this will come 3 by 2 and this will come 16.16 gigahertz. 16.16 gigahertz. So, this is the cutoff frequency for the TM11 mode. From this we will get the this wave impedance easily. So, eta TM11 will be eta square root of 1 minus f c upon f whole square. So, we can substitute the value. So, 377 square root of 1 minus f c 16.16 by operating frequency will be same whole square. So, this will come 166.05 ohm. So, this is the wave impedance for the TM11 mode. So, we can see that wave impedance for the TE10 mode is more. So, and that is also greater than 377, that is wave impedance of the free space, but for the TM mode it is less than free space wave impedance. So, this is the solution for the second part. Now, we can go to the next second question. If the waveguide of problem 1 is filled with a medium that is characterized by sigma is equal to 0, epsilon equal to 4 into epsilon naught, mu r is equal to 1. Now, this waveguide means air filled rectangular waveguide of problem 1 is filled with permittivity, relative permittivity is 4, means it is filled with the material has relative permittivity 4. So, what is the new wave impedance of the TE10 and TM11 mode of propagation in the waveguide at the same frequency at 18 gigahertz. So, problem is same, just waveguide is filled with permittivity of means relative permittivity is 4. So, in the second part, so in the second problem, so we have to go in the similar way, but here we have to careful in the calculation of eta TE. So, eta T formula will be same, but for FC will be changed. Cutoff frequency is dependent on the relative permittivity. So, here it is u by 2 a square root of m by a plus n by b whole square. So, FC will be changed. So, first we can do for TE10 mode. For the second problem, so FC for the TE10 mode, so FC we can calculate, that is u by 2 a square root of m by a whole square plus n by b whole square. Because n is 0, we can write this as u m by 2a. We can write like this, u m by 2a, and m is 1. So, it will be u by 2a, and u for this case u will be 1 by mu epsilon, and we can write mu epsilon as mu naught mu r epsilon naught epsilon r. So, this will be 1 by a square root of epsilon naught mu naught into 1 by mu r epsilon r. Here mu r is 1, epsilon r will be 4, and this part is the free space impedance. From this we will get 3 into 10 to the power 8 into 1 by a square root of 4. So, it will be 3 by 2 into 10 to the power 8 equal to 1.5 into 10 to the power 8 meter per second. So, this is the u for the u, this is u for this case. So, FC can be calculated, FC will be FC for the TE10 means FC for TE10 will be u by 2a. So, u is 1.5 into 10 to the power 8 divided with 2 into age 2.5. So, all the dimensions are same, 2.5 centimeter. So, we have to make in the meter. So, it will be this FC for TE10 mode. FC for TE10 mode, and this will be after calculation, this will be, so this 2.55 and then 10 will go, then 3 gigahertz. 3 gigahertz Fc for the T10 mode, and eta t, then eta T10 will be eta divided with a square root of 1 minus Fc by F. So, eta Te10 will be eta divided with a square root of 1 minus Fc upon F whole square. We can see that eta is defined as, means in this expression eta is defined as a square root of mu by epsilon. So, here eta we can write as eta will be a square root of mu naught mu r divided with epsilon naught r equal to, we can write like mu naught divided with epsilon naught into a square root of mu r epsilon r. So, this first part will be 120 pi into the second part, upper part is 1, mu r is 1, epsilon r will be 4. So, square root of 4 will be 2 and this will be 60 pi ohm. So, this is the means eta for this case. From this we can substitute all the value Fc and this eta in the T10 mode. So, wave impedance for the T10 mode, will be eta 1 minus Fc whole square. So, it will be 60 pi divided with a square root of 1 minus Fc is 3 gigahertz, 3 that is gigahertz, 18 is also in gigahertz. So, that is cancelled and then this will be the answer, 60 pi divided with a square root of 1 minus 3 by 18. So, after calculation this will come 188.5, that is upper part, divided with 0.986, it will come 191.17 ohm. So, this is the eta t for the 10 mode. So, we can see that it is reduced, eta is already reduced. So, 60 pi that means it is 188.5. So, this 188.5. So, but it is for the t it is more than eta. For T10 mode it is more than eta, that is 191.17. Similarly, we can calculate the wave impedance for the TM11 mode. For the TM11 mode we know formula is TM11 mode eta a square root of 1 minus Fc upon F whole square. So, Fc we have to calculate because Fc is unknown here, it will change for every mode. So, Fc will be, so so u upon 2 a square root of m by a whole square plus n by b whole square, and u will be same, means like in the previous, for each mode u will be same. So, u will be, we have calculated because this is only depending on the 1 by mu epsilon, that means 1.5 into 10 to the power 8 meter per second. So, in this case also u will be same, that is 1.5 into 10 to the power 8 by 2 a square root of 1 divided with 2.5 10 to the power minus 2 whole square plus 1 by 1 into 10 to the power minus 2 whole square. This will come. So, after calculation it will come 8.08 gigahertz. So, this is the cutoff frequency for the TM11 mode. After this, so eta will also same like T10 mode, that will be 188.5 and Fc is known, F is known. So, now we can directly substitute all the value. Tm 11 will be this 188.5 into a square root of 1 minus 8.08 divided with 18 whole square. This will come 168. So, we can see that this is less than 188.5. So, this is the wave impedance for the TM11 mode. Now, we can go to the next problem. So, what is the wave impedance for the T10 and TM11 mode of propagation? In the next part, an air filled rectangular waveguide has cross sectional dimension A equal to 6 cm, B equal to 3 cm, given E z is equal to 5 sin 2 pi x by a sin 3 pi by b cos 10 to the power 12 t minus beta z volt per meter. Calculate the intrinsic impedance of this mode, because this impedance is depending on the mode of operation. So, calculate the intrinsic impedance for of this mode and the average power flow in the guide. For this mode, we have to calculate the average power flow in the guide and intrinsic wave impedance. So, to do this, before we have to, so we can see that, so this is E z is given, E z is given. So, this will be, so this will come under means TM mode, TM to Z mode. E z is given, so this will come under TM to Z mode. And third problem, for the third problem, so a standard equation we know, means E z equal to, E z is defined as E naught sin of m pi x by a into sin of n pi by b e to the power minus of gamma z. So, it is a standard equation, it can be defined like this, it can be written like this, and from the given E z we can find out all the field component, means for the TM to Z mode. This is for the TM to Z mode. So, for the given E z we can find out all the field component for this from this E z. So, that E x is defined as, means E x from this E x is defined as, so this will come from the Maxwell equation, minus of gamma by h square del of E z by del x. So, this is the expression for the E x in terms of E z. Here gamma is the alpha plus j beta, h square is gamma square plus k square equal to k x square plus k by square equal to, means here h square, means h square is gamma square plus k square, k is omega root under mu epsilon, and this will be, means h square will be this, means this will be k x square plus k y square equal to m pi, means m pi by a whole square plus n pi by b whole square. So, like this k x is m pi by a, k y is n pi by b. So, h square can be defined like this. E x can be written as, E x we can get the, means from this expression, minus of gamma by h square del E z upon del x. So, because here it is a partial differentiation. So, this will only differentiate on the x component, and from this m pi by a will come outside. So, this will be E naught minus gamma h square by h square. So, E x can be written as, E x will be minus of gamma h square, because the partial differentiation is on x. So, m pi by a E naught, and sin will be cos m pi x it is differentiation, means sign will be cos sin of n pi by b e to the power minus gamma z. So, E x can be defined like this. Similarly, E z means E by is E by from E z can be written like this, minus of gamma by h square del of E z upon del y. So, in this case it will be partial differentiation is will on only by component, and this will come minus of gamma h square n pi by b E naught sin of m pi x by a, and this second term will be cos because of differentiation and b, and this will be e to the power minus gamma z. E x, E y and h x, h y, because we will need all these component in the power flow, in the computation of power flow. H x will be j omega epsilon by h square del of E z by del y. This will come j omega epsilon by h square del y, means n pi by b, differentiation is on by, and that is second term E naught sin of m pi x by a. So, here second term will be cos n pi by b e to the power minus gamma z. Similarly, next we will get the h y will be, so this is only for the Tm to Z mode. So, h y will be minus of j omega epsilon by h square del of del E z by del x square. So, this will come minus of j omega epsilon by h square. So, this is on x. So, it will be m pi by a E naught, that will be cos m pi x by a sin n pi by b e to the power minus gamma z. So, we can, so and h z will be 0 because this is for the Tm to Z mode, and k square is omega square mu epsilon, and h square we have defined, means h square equal to gamma square plus k square, and for the cutoff case means gamma will be 0, and fc we will get from there, and for the Johansen mode and propagating mode we will get for the power flow. So, it can be, means for the cutoff case it will be, means gamma will be 0, that is gamma is the propagation constant in the z direction, that is alpha plus j beta. So, gamma will be 0, and this will be, means h square is gamma square plus k square, that is equal to kx square plus k by square. If gamma will be 0 and k square will be omega square mu epsilon, and this is the condition for the cutoff to compute the cutoff frequency. From this, so this will be omega c whole square mu epsilon equal to m pi a whole square plus n pi by b whole square. From this we will get the cutoff frequency. So, that we have used in the omega c will be 1 by a square root of mu epsilon, a square root of m pi by a whole square plus n pi by b whole square. So, we will, so this is the condition for the cutoff frequency, and in the second part for the Evanson mode, so there means k square, that is omega square mu epsilon, that will be less than m pi by a plus n pi by b. So, in this case this k square, that will be less than this condition, and in this case, so in this case gamma will be alpha, means that will be attenuated, wave will be attenuated, that will not flow in the waveguide, gamma will be alpha and there will be no propagation, beta will be 0. Because we can see that gamma square equal to means k x square plus k y square minus k square. Gamma square equal to k x square plus k y square minus k square, and if this term means if so if k square will be less, so this will be positive and gamma will be positive quantity. If gamma is positive quantity, that means that this will be alpha, because this is less, means k square will be less. So, this will be positive quantity, this will be positive, there will be no means only real, this will be real quantity, and inside of the positive number it will give the some real number, that means gamma will be only alpha and beta will be 0, means imaginary part will be 0. That means, so we have defined means propagation constant in the z direction at e to the power minus gamma z, e to the power minus gamma z, and if gamma will be alpha, minus of alpha z. So, if alpha is some positive number, so it will get attenuated, it will not propagate inside the waveguide. Next is the condition for the propagation. Condition for the propagation is k square equal to omega square mu s epsilon should be greater than m pi by a whole square plus n pi by b whole square. So, here k square will be greater, that means gamma square will be, so this will be negative this will be negative, means gamma square inside gamma will be a square root of k x square plus k y square minus k square. So, if k square is greater than this summation, means k x square plus k y square, that means inside it will be negative and this will be purely imaginary number. So, gamma will be purely imaginary, in that case gamma will be j beta and alpha will be 0. So, if gamma will be j beta and alpha will be 0, in that case we will get e to the power minus of gamma z, if gamma will be j alpha, e to the power minus j beta alpha. So, in this case it will not attenuate, but it will propagate along the z direction. So, from this expression we can compute the power flow in the waveguide. Similarly, we can write for the, this is for the Tm to Z mode, we will compute the power flow for this Tm to Z mode, and we will do the third problem. And similarly, for the T to Z mode, this can be also written. Similarly, for the T to Z mode, for T to Z mode, for the T to Z mode, Hz will be H naught cos of m pi x by a cos of n pi, here it will start from 0, m or n it will start from 0, because this will be 1. So, Hz will be there, e to the power minus gamma z, and Ez will be 0 for this case, Ez will be 0. Okay. We will continue in the next class. Thank you.